Alright everybody, good afternoon. This is Andrew here from Central Illinois Weather, and today we're going to be talking about the potential for a significant severe weather event tomorrow across portions of Oklahoma, Texas, and into Kansas, and Missouri, and also into Arkansas potentially. If you want to see more videos like this with me explaining severe weather events, please like and subscribe. That gives me an idea of how this is going. So let's start off with the Storm Prediction Center's outlook as we normally do. There's a moderate risk now across portions of Oklahoma and Texas. We have a marginal first, though, going into Illinois, Missouri, Iowa, Kansas, Nebraska, into surrounding areas, into Texas, Oklahoma, and Arkansas. Surrounding that, we have a slight risk across like Wichita, Liberal, and into Kansas, and then up to Kansas City, Missouri, down to Springfield, Missouri, up in northwest Arkansas, toward Fayetteville, down toward Wichita Falls in Texas. Around that, there's an enhanced risk for places like Joplin, Missouri, southeastern Kansas, like El Dorado, Tulsa, Oklahoma, Norman, and OKC, basically the OKC metro, and Woodward, Oklahoma as well, and then goes all the way into the Panhandle there. Along with that, there is a moderate risk mainly in southwest Oklahoma for places like Altus, Enid, Elk City, El Reno, and Weatherford, Oklahoma. We could see this get expanded soon. There's a 5% tornado prob. I am expecting this to get expanded something like this, and probably have a 10 hatched added as well. Our main reason for having a moderate is for wind. There is a huge SIG wind area from Springfield, Missouri, all the way down into the Texas Panhandle. Hail is a 15% risk across Kansas, Oklahoma, and Texas. Day 3, there's also a severe chance in Indianapolis and places like that, in Ohio, Kentucky. I do think this will probably get into Illinois, as that squall line will continue to roll through places like Illinois. Timing was a little uncertain at that point. Day 4 through 8, we're also watching an event from day 6 through day 8, which will probably have one or two severe risks added in the next cycle. Let's first talk about our severe risk for tomorrow, though. So let's go into the HRRR, and let's first go over the reflectivity aspects of it, and then we'll go into it kinematically. So we're expecting a low top squall line to start to develop out there in New Mexico, but first, with maybe some stronger storm potential out there. Potential for a couple wind gusts, and that's about it. Around 23Z, we're expecting initiation. 22 to 23Z, we're expecting storm initiation in Kansas, the Oklahoma Panhandle, down to the Texas Panhandle. Stronger tornadoes and very large hail will be possible initially. Here is a box sounding throughout the eastern part of the Panhandle. Very streamwise profiles within the 0 to 6 kilometer, and throughout the upper level wind profile as well. There's a small capping inversion, but this could get eliminated as there's currently cloud clearing, which wasn't expected at this point. Steep lapse rates, along with solid 3 cape and decent thermodynamics for this time of the year, will also help. If we do a smaller box sounding, mainly encompassing the southern part of this, you will see the environment is quite potent, with very strong wind shear throughout it and pretty decent thermodynamic profiles. As we get further into the night, this line is expected to strengthen across Oklahoma. We're probably going to have a couple hour window of discrete supercells before we go upscale. There's the small stable layer, but this will likely get punched through as we have an extremely strong low-level jet narrated by this photograph here, and also with 850 millibar winds being 40. Now moving into further into the night, we're expecting this intense line to kind of move through and still kind of keep track Texas with severe potential all the way into kind of the Mississippi River Valley region, and we can look at this throughout the Ohio Valley sector, and we can kind of see it per this MCS or QLCS progress eastward, not MCS, and we can see it starts to get up toward Kansas City around midnight and into the Joplin area at that point too, and we see this crossing into Illinois early morning around 4 a.m. Gaining a little bit of strength there in the central Illinois. There's going to be some low instability to some extent, and this line kind of breaks into some mini supercell type structures as you get into Ohio, Indiana, Kentucky, as the forcing kind of dies down. Now looking into the kinematics, this is a pretty classic kinematic look for something in the cold season for a significant severe weather type setup. Looking into it here, 850 millibar, you have at 0Z, you have extremely strong 850 millibar winds at 60 plus knots across the warm sector. Along with that, your 500 millibar winds are pretty good off the boundary, especially in like southwest and into the Texas Panhandle. So initially, storms will be discreet. But given the degree of forcing we have a very strong amount of forcing because that low-level trough center is right there. You have a very strong amount of forcing with this 100 knot plus belt of shear there. You can see this is a pretty classic look for a significant MCS potential derecho setup. 700 millibar winds at 3 kilometers are extremely strong at like 80 plus knots, it looks like here. Yeah, 80 knots and higher. And this is 700 millibar is where you need to look at to see if your winds are perpendicular to the QLCS line. And this line movement is, for the most part, kind of east-northeast, like this. This is pretty much 90 degrees off of it. So you're going to have potential for significant tornadoes within the line. And that's mainly going to start up around 1Z or so once this grows upscale. Which will likely happen around 1Z. And you can see it's still there. The LLJ strengthens even more, 90 knots at 0 to 3 kilometer. And if we look at the 3 Cape as well, it is there, 100 plus joules per kilogram along the front. We can take a small box sounding. This probably will be convectively contaminated, yep, but you can see this photograph favors significant tornadoes. And that low-level profile does as well. You can see steep middle lapse rates are being ejected into the line, so damaging wind gusts won't really have too much of a problem translating down unless that stout inversion gets in the way. But these things should be surface-based as they'll start off. Now, I'm thinking a little bit earlier into the day, I think storms will probably start off high-based. And they'll probably start off being discrete as well as your barbs are pretty, they're not parallel, or they're not perpendicular, but they're not parallel either. They're pretty perpendicular to the boundary motion. But the thing is that not the most perpendicular, and yeah, boundary layer moisture arriving late is a possibility, but it's becoming more unlikely. You can see here the more sufficient boundary layer moisture is generally in here at 22Z, and that's expected to shoot further to the north. So you probably won't have too much of a problem getting that further northward. Looking at the wind gusts just ahead of the line, they're 40 plus miles per hour. This is along the cold front there, and as you get toward 1Z, you can see these wind gusts in front of the line, 30 to 40 plus miles per hour, just influencing the moisture, and you can see there's 60 plus miles per hour within the line. I've seen some 90s get spit out with this as well. We're probably going to see 75 mile per hour wind gusts be a possibility throughout the night there. Looking into the HRRR's 0 to 3 kilometer updraft helicity swaths, and we're going to go to a continental United States view to look at this. As this seems pretty impressive generally, but they are quite strong, and you can kind of get the sense of these. This line will the HRRR suggests that this line will be pretty significant from portions of the Texas Panhandle where it's more supercellular, through Oklahoma and into Illinois. This is the area generally outpaints for the better severe risk, and that's where the SPC has the risk outlined. Looks like the more significant severe risk will probably be in here, most likely. Or the more intense updrafts in the HRRR are showcased in here generally, which isn't surprising because that's pretty much the SPC SIG wind region. So yeah, now let's go into other cams and look at the NSSL. The NSSL has a pretty similar output along with the ARW. Now these are models that do put the moisture a bit late. The moisture is probably going to arrive on time and be maybe slightly better than the HRRR projects, which is quite interesting. But here is the ARW, and it shows dew points at 23Z, which is 5 p.m. They're barely into the upper 50s there, tongue of low 60s as well. Taking a sounding along that moisture tongue, it is quite a significant environment there, so you're probably going to see a strong tornado threat initially. The SPC mentioned the potential for strong tornadoes in their discussion, but this risk is kind of conditional. As we get toward, we're probably going to see pretty instant growth into a linear segment. Probably have a 1 to 2 hour window of discrete supercells across southwest Oklahoma and into the Texas Panhandle before we see that strong upper air ascent really kick in and these things start to become more of an embedded line segment. You can see the ARW has 500 plus joules per kilogram of CAPE and sufficient low photographs there across southwest Oklahoma. That same environment gets pumped up into central Oklahoma, less instability, but that'll probably be a bit different than that. And this is all with the same general idea, except a little bit less instability. I think the NSSL in the instability department is definitely the most unrealistic. It does not really have that moisture arriving there on time. It has the moisture. This is where the HRRR has it like 20 to 21Z, and it has that moisture just not being there, which is interesting. The FV3 is definitely the most aggressive with the moisture in this event. It has low 60s up into, well, pretty far up into the Panhandle, with low 60s up into Oklahoma City as well. It's also the most aggressive with its output. It's going full on supercellular for a couple hours, which is interesting. I don't think it's going to happen like that, but you never know. FV3 has a couple pretty big time supercells that are firing up there along the front. At 0Z, if we look at forecast soundings, I mean, this is just strong tornadoes and significant wind gusts just painted all over it. We can see at 1Z it starts to develop these more intense storms. I think 3Z is probably the one. Yeah, it doesn't even fully upscale. It's just a line of embedded supercells and 500 mixed layer CAPE and SRH in the 1 kilometer of, let's see, it's probably very high, like 200 to 400. I don't think it's probably gonna be higher than that, but very impressive wind fields are going to be there. Now, looking further out, we're really only going to use ensembles to this point because they're probably going to be the more accurate models. And we're going to look at these for Thursday. Thursday, we're expecting a dry line across portions of Texas that will eventually morph into a cold front. Severe risk will probably take place somewhere in this general region, 12Z through 12Z. Thursday could extend further to the north and probably will extend further to the north like that. Could even extend more north. We're expecting a tongue of 500 joules per kilogram of CAPE to extend up here as well. 50% chance of 500 millibar or 500 surface-based CAPE is getting up into Arkansas, Mississippi, Texas there. This is where your maxed ingredients are on the GFS, and they're centered over Texas, Louisiana, Arkansas, and Mississippi through Alabama. You can see this risk shifts further to the east throughout the night. And then as we get into Friday, it kind of weakens down. Friday could be more of a, probably will be a little bit more lower end than Thursday will at this point, with the ensembles projecting what they do. We have a shot at 500 CAPE, service CAPE from Virginia down to Florida and Georgia, with 60s dew points being prevalent across those areas in upper 50s. This trough starts to kind of exit the CONUS, United States as well. Euro is a little bit faster with this system, but it still has the same general idea, with 500 mixed layer CAPE being likely across a large area. Extremely likely across Louisiana and coastal Texas and into Mississippi there. 500 millibar winds are generally in agreement with the GFS. It's slightly faster though. Still an intense trough is expected, and it moves into the eastern seaboard the next day with 60s dew points in Georgia, Alabama, I think, once this loads. Yep. South Carolina, Florida too. 500 ml CAPE, surface-based CAPE, is likely to be in place across Mississippi, most likely Mississippi, Alabama, Florida Panhandle at this point, and then shifting eastward into Georgia, Alabama, South Carolina, Tennessee. So we're watching this for a severe threat as well. Thursday and Friday could potentially be more of a significant threat as well. It's just something to watch. Thank you guys for watching this video, and I'll see you in the next one.